Welcome, everybody. My name is Diego Grinman. I'm a postdoctoral associate at Yale University here in the US. And I'm here today on behalf of HubLE with my friend Marco Ponzetti from University of L'Aquila to talk about the recent publication titled Lipocalin-2 Influences Bone and Muscle Phenotype in the MDX mouse model of Duchenne muscular dystrophy, which was published in the International Journal of Molecular Sciences. Is that correct, Marco?
Yeah, it is. Thank
awesome.
you. Thank you, Diego.
Do you want to introduce yourself to the HubLE audience?
Sure. So as Diego said, I'm Marco Ponzetti, and I'm also part of HubLE, actually. So I'm really happy to participate from the other side of the camera, so to speak. Yeah. So yeah, actually, I'm a postdoctoral researcher at the University of L'Aquila. I'm recently working more on the bone metastases field with extracellular vesicles, but Lipocalin-2 has always been a part of my heart, and it's always there, so I'm keeping working on it, and yeah.
Yeah, and it's also a hot topic, Lipocalin-2 is mentioned everywhere since that, paper talking about Lipocalin-2 and anorexia stuff. Everybody was talking about, bone-derived molecules that can influence both, energy metabolism and also, bone physiology. So what you want to give us like a little summary of your work so we can be introduced to that topic as well?
Yeah, sure. So yeah, as you said, Lipocalin-2 has been really hot topic for a while. And well, in our lab, we actually started researching Lipocalin-2 in bone in 2009. So it's a pretty while back. And so in our first paper about Lipocalin-2, I wasn't even a researcher then. And what the paper found was that when you put Lipocalin-2 when you put wild-type osteoblasts in microgravity conditions, so that means with low mechanical loading, Lipocalin-2 is the gene that is most upregulated among all of the genome of the transcriptome of osteoblasts. Lipocalin-2 is the one that responds more severely, so it's very upregulated. So starting from there and moving on to a couple more papers where we found that Lipocalin-2 was actually playing an active role in the bone loss induced by mechanical unloading. We eventually landed on this project that. And how did that happen? Basically, that happened because we had some MDX mice, and MDX mice, let's say they are a model for both mechanical unloading and inflammation-induced osteoporosis. Basically, they have low bone mass, and so do the children that have Duchenne muscular dystrophy.
Right.
And so basically, we just analyzed Lipocalin-2 expression in their femurs, and turns out it was upregulated. So that's how it all started.
Right. Yeah. So tell us a little bit more about Duchenne muscular dystrophy. I mean, we know that it's a rare disease, but just give us a brief summary of how does it work and what's the impact on the patients.
Yeah, Duchenne muscular dystrophy actually is a rare disease, but it's not as rare as you might think. Up to 1 in 1,000 live births have Duchenne muscular dystrophy. Of course, it's an X-linked disease, so it basically only affects male. But boys with Duchenne muscular dystrophy have a really hard life, actually. And their muscles, they are quickly replaced by fat tissue and fibrotic tissue over the years because basically they lack this protein called dystrophin that is a really important protein in maintaining the structural integrity of the muscle. And so there is some pretty good therapeutic let's say method in place, but still these boys live up to 40, maybe 50 years of age, and they are wheelchair bound by 10 or 12 years of age. So it's really tough life, and of course their heart suffers too. So they eventually die of either heart or pulmonary complications or respiratory complications. Really tough.
So this is a clinical unmet need of finding new therapeutic approaches, right, to this particular disease, and that's where your work comes in, right?
Yeah.
Found.
Yeah, another thing that people don't really think about is the role of bone in Duchenne muscular dystrophy. And I mean, you would say, okay, but this boy is, you know, really severe muscle phenotype. Who cares about bone? But actually, bone is pretty important because maintaining bone health in Duchenne muscular dystrophy can help boys maintain their ambulatory status for longer, which is really important because once the boys are wheelchair bound, they basically never get up. And that happens quite often because they fracture quite frequently. And yeah, that's the part we wanted to help with in a way. And we thought that lipocalin-2 might have been the way to do that. Of course, this is just a first part of the work. It's a first step, but yeah.
So tell us, what was your main finding in this paper?
Yeah. So in addition to finding that lipocalin-2 was increased in femurs, we actually found that also circulating levels of lipocalin-2 in the serum were increased. And that was the first finding that led us to think, okay, maybe this lipocalin-2, what happens if we remove it? Is it the same as mechanical unloading induced osteoporosis, that we can make things a little bit better? And so we got our mouse models, very simple ones. We had the MDX mouse model, which is the main Duchenne muscular dystrophy model. And we basically crossbred it with lipocalin-2 knockout mice, so mice that lack lipocalin-2. And we grew them to 3 months of age, 6 months of age, 12 months of age. And we analyzed their bone and muscle phenotype at different ages. And we noticed that when you remove lipocalin-2, basically you're able to improve both the bone phenotype and a little bit even the muscle phenotype. And that kind of fits in the idea that these two tissues are tightly interconnected. So we don't really know what comes first, but we do know that it helps removing lipocalin-2. And but to give the work a, you know, mouse genetics is always, you know, not the very best way to demonstrate things, or at least it can be a part, but you have to demonstrate it in other ways. We also treated these MDX mice with a lipocalin-2 blocking antibody. So, and this antibody is able to basically prevent the action of lipocalin-2. And what happens when you treat MDX mice with this antibody is kind of the same as the mouse genetic studies, just a bit milder. So you still have an improvement of the bone phenotype, you still have an improvement of the muscle phenotype, but let's say if you start blocking it like very, very early, it's better, of course. We treat for about a month, and that is enough to help. But of course, it does not cure the phenotype. The bone phenotype is quite well rescued. The muscle phenotype, of course, is still very severe.
So, so the prediction is that patients with Duchenne muscular dystrophy may have high levels of lipocalin-2, and you know, is that something that you have in mind, you know, to explore in the near future, you know, to see serum levels of lipocalin-2 in patients with that disease?
Yeah, we actually we were actually talking with a person who manages this kind of rare disease patients about this, and we hope we can get a hold of a few sera and see if the lipocalin-2 is increased in these boys. The possible problem is that lipocalin-2 being very responsive to inflammation, is that these boys are usually treated with glucocorticoids right away. And glucocorticoids, of course, are probably the most potent anti-inflammatory drugs there are. So we don't know for sure if we will find it upregulated, but if we don't, it probably deposes in favor of the use of glucocorticoids because it means they're keeping it low. Yeah. So anyway, yeah, that's a really good suggestion, which we think we might go through with. We're trying it.
That's fantastic. Yeah, I read your work and it was very interesting. And one of the things that, you know, we like to highlight in here is the actual, you know, work that you've done and the problems that you have. Did you find any challenge during the process of the publication of this paper, the work that you've done? things that were wrong, which are totally okay, because we know in science things work and sometimes
Yes, they
it doesn't.
were.
Exactly.
Of course.
So, yeah.
Well, just to give you an idea, this work started in 2016.
Wow.
So it took a really long time to get to this point. Yeah, there were many challenges. It was during my PhD, so of course everyone's PhD is is tough. You work on a lot of things, and yeah, and also the fact that we even had 12-month-old mice with all the crossbreedings. We had six different mouse lines to work with, basically. So we had 3 different ages, 6 different lines, and we were crossbreeding and doing sacrifice. So it was a mess, but eventually, eventually, yeah, we managed to finish it. It was a very long process, not because it was a super complicated science. It's a very simple paper, but because there are a lot of experiments involved.
Yeah,
and a lot of mouse studies.
right. And all this, keeping genetic breedings and, all the stuff, it's always complicated, but you did a pretty good job in there. So congratulations.
Thank you very much.
So Marco, what's next in your career? I mean, so this was your PhD. That means that you're a postdoc now. Well, what's your next, thing? What's your next challenge, your goal?
Well, right now I am working in the same lab where I did this work, but I'm focusing more on cancer now, because I've always worked on cancer, and it's sort of my main drive in science. And I'm recently, well, not very recently, but we are working on extracellular vesicles mostly. And that's what I'm really focusing on now, the role of extracellular vesicles in the vicious cycle of bone metastases and osteosarcoma. And turns out the lipocalin-2 is involved in that as well. So we're it's everywhere. I'm telling you, it's everywhere. So when you treat osteoblasts with the extracellular vesicle from breast cancer, lipocalin-2 goes through the roof. Yeah, so that's what's next for me.
Well,
so spoiler alert.
Yeah, we have to discuss a little bit our projects together. We might have something in common there. So,
sure.
So Marco, I think we're running out of time. So thank you so much for this interview, and thank you all the HubLE audience for being here and supporting, good science. And of course, if you want to tell your story as well, please communicate with us. You can follow us in our Twitter at IFMRS HubLE. Just ideas, publications, exchanges, whatever you want to share, just be in contact with us. And Marco, to finish, do you use Twitter? Do you want to, share with us your Twitter handle? So if anybody has questions for your work, can ask.
Yeah, sure. I do use Twitter. My handle is at Ponz91, PONZ91. So yeah, look me up.
Right. Thank you so much, Marco. Thank you, everybody there, and see you around.
Thank you, Diego. Bye-bye.